Hello students, you are watching Math-O-Learn channel and I am with you, Arup sir. Students, today we will do rational and irrational numbers for class 9. Though I have written ICSE board because I am referring here Foundation Mathematics by S Aggrawal for ICSE board. But as I always say, the concepts of maths are not specific to any board, but it is common to almost all the boards, all the students. So, whatever board you are studying, this video will be very helpful. We'll talk about what are rational numbers and what are irrational numbers and what are the concepts and what you will be studying in the class 9 standard. Here I will directly do the problems. I will keep on explaining all the concepts and fundamentals for those topics. So let's begin the exercise. So first question goes like this. Without actual division, find which of the following fractions are terminating decimals. So children, there are two types of decimals. One are terminating, other are non-terminating. So terminating and non-terminating you will understand if I say 2 by 5, if you divide 2 by 5, you can see that 2 is not divisible by 5, so you put 0 point and then put a 0 after 2. So 5 4s are 20 and the remainder is 0. There is no remainder. So 2 by 5 is a terminating decimal number. This is called terminating decimal number. Terminating decimal. On the other hand, if I give 2 by 3, if I convert this in the decimal, then again I have to do the same method. I have to divide 2 by 3, but 2 is again smaller than 3, so I have to put 0 point and then put a 0 beside 2. 3 6 are 18. After subtracting, we are getting 2, again 0, and then 3 6 are 18, and you can see 6 will keep on coming. 0.66666. So this one you can see 6 is repeating, but it will never get terminated. So this, since after point 6 is getting repeated, so you can say 0.6 and 6 over 6 you can put a bar. That means 0.6, it is a non-terminating repeated decimal. This is called non-terminating repeated decimal number. So you understood, when you divide, you get either terminating or non-terminating repeated decimal. So we'll see all the rational numbers come in this category. Either they will be terminating decimal or they will be non-terminating repeated decimal. So now we will see 9 by 25 whether it will be terminating decimal or non-terminating decimal. If you divide this 9 by 25, you can easily understand, but condition is that here it is written without actual division. So there must be some concept how to find that whether it will be terminating decimal or not without actual dividing. Without actual dividing, you can determine whether it will be terminating decimal or not if you do the denominators prime factorization. If you take 25 and do prime factorization, you will get 5 into 5. If you break it with the prime numbers, that means if you factorize the 25 with prime numbers, then you will getting 5 into 5. And in this case, if the factors of the denominator are 5 only, then it is definitely terminating decimal number. So it is yes. So concept is that if the, I am writing here, if the denominators factors are only 5 or 2. Denominators factors are only 5 or 2, then they are terminating decimal. If the denominators factors are only 5 or 2, then they are terminating decimal. So in this case, 9 by 25, what we saw, 25 is only having factors of 5 and 5. So 25 has no factors other than 5, so it is terminating decimal. Let's see second example. Again we have to do 12, and 12 you know, 12 2 into 3. That means factors of 12, prime factors of 12 are 2, 2 and 3. So this is the villain, because our concept is that denominators factors should be only 5 or 2. Here 2 were there, it was fine. If only 2 would have been there, then it would have been terminating decimal. But since one of the factor is 3, so this will not be terminating decimal. Hope you are getting the point that when the denominators factors is other than 2 or 5, then it will not be terminated. Let's see number 3 also. Again, we will not bother about the numerator. We will only look into the denominator. Here the denominator is 16, and 16 is 2 into 2 into 2 into 2. That means 2 to the power 4. So clearly denominator has only factors of 2, so this is terminating decimal. So you should be very perfect in doing prime factorization, and you have to see whether the factors are only 2 or 5. 128. You know 2 into 64. That means 64 again 2 into 32. 32 again 2 to the power 5. That means 128 also 2 to the power 7. So 128 also has factors of only 2. So you can say that this is terminating decimal. Let's look number 5, where denominator is 50. 50, 2 into 5 square. 2 is also allowed. The factor of 2 is also allowed. The factors of 5 also allowed in the denominator. But other than 2 and 5 are not allowed to be a terminating decimal number. So here we can see the denominator has only factors of 2 and 5. So this is also terminating decimal. Here also you can see 125, 125, 5 25s are. So 5 to the power 3 is 125. So this is also, yes, it is terminating decimal number. Let's see number 7, where denominator is 55. 55, if you see 55 equal to 5 into 11. 5 is also prime number, 11 is also prime number, but here our condition is denominator's factor should be only 5 or 2, not other than 5 or 2. So here 11 is there. Easily we can see that 19 by 55 will not be terminating decimal if you divide it actually. Let's look into this. Number 8, 78. 78 equal to 2 into 39. Again, we can say 2 into 3 into 13. That means 78's factors are 2, 3 and 13. So neither 3 is desirable nor 13 is desirable. So this is definitely not going to be terminated if you divide. Let's see number 9, 80. 80 you know 8 into 10. 8 is 2 to the power 3 and 10 is 2 into 5. So here also you can clearly notice that 80's factors are only 2 and 5. So you can clearly say this is terminatable. This is terminating decimal number. Again, number 10, 30, we have to see only denominator. 30 equal to 3 into 2 into 5. Everything was correct. 2 and 5 were correct, but 3, it is not allowed. Other than 2 and 5, none of the prime numbers are allowed to be terminating decimal. So 19 by 30 also will not be a terminating decimal number. Hope this concept you understood, how to identify whether the number will be terminating decimal or not without actual dividing. Children, second question. Convert each of the following decimals into a vulgar fraction in its lowest terms. Okay, any fraction, lowest term, you know, you have done this in your earlier classes also. What is vulgar fraction? This might be a new term for you. Vulgar fraction are the fractions whose denominators are not 10 to the power any number. That means the denominator other than 10, 100, 1000, etc. Denominator other than 10, 100, 1000, 10,000, etc. That means 10 raised to the power n, where n is any natural number, are called vulgar fraction. So the fractions in its simplest form, if the denominators are not 10, 100, 1000, 10,000, etc., this type of things, they are called vulgar fractions. So that means 3 by 10, if somebody says 7 by 100 or 3 by 1000 or anything, this type of things, 10 to the power 1, 10 to the power 2, 10 to the power 3 or so on, they are not vulgar fractions. But if you say 3 by 5, 2 by 7, 5 by 9, these all are vulgar fractions. They are called vulgar fractions. I hope explanation of vulgar fraction is enough up to this. Now you have to convert this 0.65 into its lowest form. So how do you do? 0.65, so 0.65 divided by, if you take away the decimal, that means decimal is from the right side after 2 digit, then you have to put after 1 2 zeros in the denominator, that means 65 by 100. But this is 65 by 100 is your converted fraction of 0.65. But is it in lowest term? Is it in lowest term? No, it is not in lowest term, because if you divide by 5 in the numerator and divide by 5 in the denominator also, then you get 13 5s are 65 and 25s are 100. Then 13 by 20, see 13 by 20, and now there is no more common factors of 20, 20 and 13. So this is the simplest form or lowest terms. If the denominator and numerator have no other common factor than 1, then they are called in the simplest form or lowest term. So 13 by 20 is in its lowest term. Now let's do number 2. 1.08, again now you can see the decimal is just from the right. If you count 2 digit, after 2 digit, then you will put 108, and after 1 you will put 2 zeros. Always you have to count from the right side. Right side, after 2 digit, then you have to put in the denominator after 1 2 zeros. 108 by 100. So now what will be the common factors in 108 and 100? You can see both are even number, so by 2 you can divide both the places. So 5 to the 10 and 4 to the 8. So 54, again you can 54 by 50. Again you can see 54 by 50. So again they both are divisible by 2. So you can divide by 2, 27 by 25. So 27 by 25 will be in the lowest term. You can make it in a mixed fraction, or you can leave like this. This multiple times you have to divide it. If you don't want to divide, and if you know this 108, if you know 108 and 100 both are divisible by 4, then you could have done in one shot. Here you can see all are vulgar fraction. They don't have in the denominator 10, 100, 1000 or so on. Let's do 0.075. So if you put 0.75, that means 75 divided by 1, 2, 3. From the right side, if you count after 3 digits, the decimal, the point occurs, then that means after 1 you have to put 1, 2, 3, 3 zeros. Now we know that 25 by 25, 75 and thousands are divisible. Then 25 3s are 75 and 25 4s are 100 and 1 0. That means 3 by 40 is your answer. Number 4, 2016 by 1, 2, 3. You have to count the digits from the right till the decimal and put that many number of zeros in the denominator. Again, if you know the divisibility rule of the 4, you can see if the last 2 digit is divisible by 4, the whole number will be divisible by 4. And 100 is always, you have to remember 25 into 4 equal to 100 and 20 into 5 equal to 100. These shortcuts will save your time in dividing. 4 5s are 20, and then 1 comes, so 1 will not be divisible by 4. Then put a 0, and again you will drop down 6, then 4 4s are 16. If you are not very confident dividing in your memory, then probably you should write it 2016 and divide it in your notebook by 4, and then you can see how 504 is coming. Many children I have seen, they don't know how to put this 0 and they make a mistake and write 54. That will be a mistake. 4 25s and 10. Again I can see that 4 and 0 is there, so both are even numbers. Both are even numbers. So 504 and in the denominator 250. You can divide again by 2. 2 to the 4. 1 is in the remainder, then 0, then 10, that means 5 to the 10 and 2 to the 4. So 252. And this will be 125. Now 252 and 125 will not have any common factors. So the lowest term will be 252 by 125. Students, number 3, convert each of the following fractions into a decimal. So here all the fractional numbers are there and you have to convert it into decimal number. So decimal number, now you understood that there can be terminating decimal or non-terminating repeated decimal number. So let's do, this is only you have to divide. So number 1, 1 by 8, that means 1 you have to divide by 8. You cannot divide 1 by 8, so you have to put a 0 point and then you can put a 0 after 1. Now this is 8 ones are 8. After subtracting you are getting 2. Decimal is there, so you can always put 1 0 in the remainder. 8 to the 16. After subtracting, you are getting 4. You put a 0 after 4 and then 5 8s are 40. So 1 by 8 equal to 0.125. You could see it is a terminating decimal number. Let's do 3 by 32. Again, 32 is 2 to the power 5. So this 32 also has only factors of 2. So this also will be a terminating decimal number. But we have to find the decimal number. So 3 by 32. So by 32 you have to divide 3. 0.0. After putting a decimal and then 0, then also 32 is greater than 30. So you have to put 0 in the quotient and you can put 1 0 more in the dividend. Now let's see, with 9 you can multiply or not. 9 to the 18, hand carry 1, 9 3 the 27, 27 plus 1, 28. 2, 1, 12. Decimal is there, so you can put always a 0. Now 3 4s are 12, but it will 128. So 4 you cannot give, 3 you can give, 3 2s are 6, 3 3s are 9. 4 24. Put a 0. 7 times 7 2s are 14 and carry 1. 7 3s are 21. 21 plus 1 22. 6 and carry 1 16. 0. Now 5 2s are 10 and carry 1. 5 3s are 15 plus 1 16. 3 by 32, you can see 0.09375. This is the answer. You have to do very carefully the division. (44 by 9). So 9 is the divisor and 44 is the dividend. You can see 4 9s are 36, remainder 8. Now 8 is smaller than 9, so here you have to put a point and then 0. 9 9s are 81, so 8 9s are 72. 8 and then again 0, and see this 8 0 will be keep on repeating. So you could see 44 by 9 equal to 4.8888. So this is repeating. So on the 8 is getting repeated. So on the 8 you have to put a bar. That means 4.888 infinite time. Number 4. 24 is the divisor and 11 is the dividend. Now again you have to put a 0 point and then put a 0. If you try with 4, 4 4s are 16, 4 2s are 8, 8 plus 1, 9. 4 and carry 1, 9, 10, 11, 14. Then again put a 0 and then if you put 6, it will be more. 5 4s are 20, 5 2s are 10, 10 plus 2, 12, 0, 2. Again 0, let's try 8. 8 4s are 32, 8 2s are 16, 16 plus 3, 19. 8. Again put 0. 24. 3s are 72. Then again you are getting 8. Now see, if you put 0, then again 3 and 72, that means this 3 will keep on repeating. That means 11 by 24 is 0.4583, and 3 is getting repeated. That means only on the 3 you have to put a bar. Express 15 by 56 as a decimal. Correct to 4 decimal places. So clearly you can see it is a division. You have to divide 15 by 56. So 56 is smaller, so you have to put 0 and then decimal and then 1 0. With 3 it will be bigger, so with 2 let's try 112, subtraction 38, again 0, let's try with 6, 6 6 are 36, 6 5 are 30, 30 plus 3, 33, 4 and carry 1, 4, 44. Put 1 0. If you with 8 it will be bigger. Let's try with 7. 7 6 are 42. 7 5 are 35. 35 plus 4, 39. 8 hand carry 1, 10, 14, 48. Put 1 0. Then you can try with 8. 6 8 are 48. 5 8 are 40. 40 plus 4, 44. 2 and carry 1, 5 is 32. Put 1 more 0. With 6, if you give 6 6 are 36, 6 5 are 30, 33. So 6 will be bigger. So you have to put 5. 5 6 are 30, 5 5 are 25, 25 plus 3, 28. Now you have to see the question. You have to give the answer correct to 4 decimal places. What is the 4 decimal places? That means you have to do some approximation or estimation. So 4 decimal places, how to do it? 1, 2, 3, 4. You have to correct this position. For correcting 4th decimal place, you have to see the 5th decimal place. Just next to 4th. That means 5th. So 5th decimal place is 5. So if it is 5 or more than 5, what you have to do? You have to increase 1 digit of the 4th decimal places. 4th place you have to increase by 1. That means this you can write 0.267 and 8 will be 9, and you can omit this 5 and can write corrected to 4 decimal places. Since you have to do correction to 4 decimal places, So you have to see the fifth place and fifth place. If it is the digit is 5 or more than 5, then you have to increase one digit, one number in the fourth place. If you would have been asked correct to 3 decimal places, in that case you have to do the division up to 4 places, and then you have to see fourth place, it is 8, 5 or more than 5, so you can write 0.26, not 7 but 7 plus 1, that means 0.268. So correcting the decimal places, you have to adopt this method. In this method, in this question, you have been asked for correcting to 4 decimal places, so you have to do the division that 4 places come in your quotient, and then you have to see the fifth place. Fifth place is 5 or more than 5, so you have to increase the fourth place by 1, and this is the answer, 0.2679. Hope you understood fourth. So 5 is the same as 4, so you can do yourself the fifth one. Now you know that if the bar is there over 2, that means it is repeating the 2 after decimal. Same like 43 by 11 equal to 3.90, that means 90 is both the digits are repeating, that means 3.909090. This type of pattern you will get. So these decimals are called non-terminating decimal numbers. So let's do again. I will say in this 6 there are few couple of sums, but I will show you 2 of them and rest you do yourself. You are smart boys and girls. I am certain that you will be able to do them. 11 by 9. You are dividing 11 by 9. So 9 ones are 9. Remainder 2. Now you have to put a decimal and 0. So 9 to the 18. Remainder 2. Again 0 and 9 to the 18. Now you know that 1.222, it will keep on coming. So this you have to write 1.2, and since 2 is repeating infinitely, so you have to say 2.1, you have to write 1.2 and a bar over 2. Let's do this also. 43 by 11. You are dividing 43 by 11. 3 11s are 33. 10 remainder. Now you have to put decimal and 0. 9 11s are 99. Then 1. Now point is there, so put 0. So it becomes 10. But still 10 is not divisible by 11. So you have to bring one more 0, but you cannot bring 2 zeros. You are only allowed to bring 1 0 because decimal is there. So if you have to put one more 0 here, first you have to put 1 0 in the quotient, then you can put another 0 in the below. Now you can do 9 11s are 99. Again remainder is 1. 1 0 you can bring because decimal is there, but still it is less than 11, so you have to put again 1 0 and put 0 here, and then 9 11 is 99. So this way you can see 3.90909090 will keep on coming. So 9 and 0 both are coming repeatedly. So 43 by 11 is 3.90909090. Then both 9 and 0 you have to put a bar over 9 and 0. So these are non-terminating repeating decimal numbers. Children, this is the last sum of the exercise, but these are the most important questions for your exam point of view. Express each of the following as a vulgar fraction in simplest form. Now vulgar fraction I've already explained. Now you have to understand how to make this 0.5 and bar over 5. That means 0.555. 5 is repeating infinitely, and you have to put it, you have to make it in a fractional number. So see very carefully, it is easy to understand, but you have to give some focus. Let x equal to 0.555 ... That means 5 is repeating infinitely. If x equal to 0.555 and so on, then if you multiply this with 10, it becomes 10 into x. And what will happen at the right side? Right side, if you multiply 0.555 with 10, it will become 5.555 and so on. You can see 0.5 into 10 because 5.5. So 0.5 and 5 repeating continuously. If multiplied by 10, it will be 5.5 repeating continuously. So if you put this equation number 1 and this is equation number 2, and then see, if you subtract this equation 1 from equation 2, subtracting equation 1 from 2, 10x minus x equal to 10x minus x, and 10x is 5.555 ... And this you are subtracting 0.555 and so on. If you subtract 5, it becomes 0, this becomes 0, this becomes 0, and all the 5's right side, whatever may be appearing in both the two numbers, they will be subtracted, and all the digits at the right side will become 0. And here is the decimal, and 5 minus 0, 5. So my left side is 10x minus x, which gives 9x. So 9x equal to 5. 5.00 means 5, because after decimal if there is 0 not followed by any other digit, non-zero, then these zeros have no value. So x equal to 5 upon 9. And you can clearly see 5 by 9 is a vulgar fraction, and that too in simplest form. So this implies 0.5 and bar over 5 equal to 5 by 9. This is the answer. How to convert the non-terminating repeating decimals into vulgar fraction in simplest form, you understood. Let's do 2 and 1 more. Then we'll close the exercise, and rest all you will do yourself. Number 2. Let's see the solution for number 2. Again we will do the same method. Let x be 0.43 and 4 and 3 are repeating. So after 4, 3, again you have to 4, 3, 4, 3 and like that. And if you multiply x with 10, then it becomes 10x, and this decimal will go, you will jump right side, that will become 4.34343433 like that. Now you see, after decimal it is 434343, but here after decimal not 43, 343434. So if you subtract as the trick you have applied in the previous sum, then the right side will not become 0. So you have to multiply one more with 10 with the 10x. So 10x into 10, it becomes 100x, and then 10 multiply here, so decimal will go after 3, that means it will become 43.434343 and like this. If I put, this is equation 1, this one equation 2 and this one equation 3, I can see the right side after decimal, then I can see the right side of decimal in equation 1 and equation 3 are same. That means 434343, here also 434343 and so on. So if I do equation 3 minus equation 1, then it becomes 100x equal to 43.434343 dot dot dot. This is equation 3, and x equal to 0.434343 dot dot dot. This is equation 1. So it is becoming 99x equal to, this right side all gets 0. You can see 0, and here it is 43. This you can write x equal to 43 by 99. So you understood 0.43 and bar over 43 is converted to 43 by 99 which is vulgar fraction in simplest form. Number 4, let x equal to 1.3 and bar over 3. That means 1.333 ... and this we can assume as equation 1. Again, if you multiply by 10, it becomes, point will jump here, so 13.333 infinitely 3. So if you do 2 minus 1, 10x equal to 13.333 ... This is equation 2, and equation 1 is x equal to 1.333 ... This is equation 1. If you subtract 1 from 2, it gives 9x equal to, right side will get 0, 0, 0, 0. So right side of the decimal becomes 0, and this 13 minus 1, 12. 9x equal to 12. So x equal to 12 by 9. 12 by 9 is not in the simplest form. Many children will write x equal to 12 by 9 and will think that he or she has done the sum correctly, but here the common factors are there. 3 4s are 12 and 3 3s are 9. So you have to divide by 3 in denominator and numerator, which becomes 3 4s are 12, 4, 3 3s are 9, 4 by 3. So you have to write 1.3 bar over 3 is equal to 4 by 3. This is the vulgar fraction in the simplest form. This will be your required answer. Friends, I hope this exercise 1A is very clear to you now. I might have skipped few of the sums that I am giving your responsibility to complete them, and I also hope that you like this video, and if you really like this video, please share with your friends and do subscribe Math-O-Learn channel. That will really inspire me, and I must be thankful to you for watching the video. Thanks again. Bye bye. Take care.